So this one is exercise related to electricity and magnetism. Figure 7.1 shows a horizontal conducting wire between the two opposite poles of the magnet. The wire XY is a circuit with ammeter. Look, here we don't have a power supply. If we don't have a power supply, which rule we should use to find the direction of induced current, right or left? Because we don't have any power supply here. We have an ammeter. So we should use the right hand rule. Why right hand? Because the simple way to identify if you don't see a power supply, right hand, because right hand rule is used to find the direction of induced current, and left hand use is to find the force on the wire which is carrying the current. Explain why the reading on the ammeter is 0 when XY is not moving. Why the reading is 0 when XY is not moving? Yeah, no change in a magnetic field. No, it does not cuts the magnetic field. That's also a term. Or no change in magnetic flux linkage. You can mention that as well. So no change in magnetic flux or magnetic flux linkage. You can use chat, you can use mic or screen annotation to answer. The wire is moved. There's a deflection on the ammeter that indicate there's a current from X to Y. So on a table, we have to take the movement of X, Y and explain your answer. So look, in the question, they mention the current is from X to Y and we have to use a right hand rule. So if you want to use a right hand rule, so your index finger will point towards the direction of a magnetic field, which is towards south. Your second finger represent, because we know the direction of the current here. So current is from X to Y means into. So where thumb is pointing? Upward. So if the thumb is pointing upward means this wire is being moved upward. So motion of this wire or movement of this wire is upward. We use a left hand rule to find the direction of the force if there is a supply, if there is a current. But actually what happened, this wire is being moved and the movement of the wire produces a current from X to Y. So the best way to identify whether a right or a left, if you don't see any supply, right. If you see a supply, power source, use a left hand. So what actually happened, we have a magnet, we have the poles, two magnetic poles. The wire is there in a magnetic field. We move the wire, and because of the motion of wire, there is a change in magnetic field, and this change in magnetic field produce a current from X to Y. So that's why the direction of the force is upward or top of the page. So place one tick which indicate the movement of XY, which direction XY has moved. To the top of the page. And explanation here, the explanation, first thing, the wire is perpendicular to magnetic field and there's a change in magnetic field which produce a current, and using a right hand rule we worked out this. I will show the marking scheme answer, like the points which you should include. See, the top of the page we take that, score 1 mark. Then current, motion and magnetic field, they are mutually right angle, means all are 90° to each other. And then the magnetic field is from left to right, or you mentioned using a right hand rule, it's the same thing. So whenever you don't see a supply, you will use a right hand. If there's a supply, use a left hand, even though you need a current or you need a force. So if you need a current or a force without supply, right hand; with supply, left hand. State what is observed on ammeter when XY is moved in opposite direction as B. So if first we were moving up, now we are moving down. So what will happen? So it will move in opposite direction. It is move in the same direction but at a greater speed. So it will be a large deflection or a greater deflection. So if we move in the same direction but at a higher speed, so it will be a greater deflection or a large deflection or more induced EMF, greater induced EMF. Define EMF, electromotive force. What is EMF? It is a work done on a unit charge to move around a closed circuit, or energy needed to move 1 coulomb of a charge around a closed circuit when chemical energy changes to electrical energy. Learn the standard definitions. I have shared the file also related to definition. So try to learn the standard one, because these are free marks. Like, you should learn and then write the same answer. Figure 8.1 shows a source of EMF which is 60. The heater H is 22.5 ohms, and the potential difference across it is 45. So this is a 60 volt supply. This is 45. How much is this one? Yes, it will be 15. So this will be 15. And we need the power of the heater. So if we need the power of heater, resistance and voltage, so P is equals to V square over R. So 45 square divided by 22.5, you'll get 90.